The breathing is steady for a while, then it stops. The room may stay completely quiet. The person in bed may not sit up, open their eyes, or remember anything about the interruption the next morning. A few seconds later, breathing returns, sometimes with a snort, sometimes with a gasp. Then the rhythm settles again. From across the room, it can look like a brief breathing problem that corrected itself. Inside the body, more has happened. In obstructive sleep apnea, the upper airway repeatedly narrows or closes during sleep. Airflow can fall sharply or stop even though the chest and breathing muscles are still trying to pull air in. The body has not simply stopped making an effort to breathe. It may be pulling against a blocked airway. When that happens, the pressure inside the chest can become much more negative than it would during normal breathing. That changes the mechanical environment around the heart and the large blood vessels. At the same time, oxygen in the blood may begin to fall, while carbon dioxide can rise. And as the brain detects that breathing has been disrupted, it may trigger a very brief arousal from sleep. That does not necessarily mean the person becomes fully conscious. They may never remember it, but the nervous system can still shift toward a more alert state. The part of the nervous system that helps prepare the cardiovascular system for action can become more active. Heart rate may change. Blood vessels may tighten. Blood pressure can move upward as the body responds to the interruption. If you like seeing what the cardiovascular system is doing during the parts of the day we rarely notice, subscribe to The Quiet Heart. That is the kind of quiet physiology we investigate here. Then the airway opens. Breathing returns. The person settles back into sleep. The entire sequence may have taken only seconds. The American Heart Association describes obstructive sleep apnea as more than repeated airway blockage. The condition can involve intermittent drops in oxygen, changes in automatic nervous system activity, and fragmented sleep. A major cardiovascular review published in 2024 describes several forces that can overlap during these events. Changes in blood gases, brief arousals, large pressure swings inside the chest, and increased sympathetic activity. Those forces do not arrive as separate chapters. They can overlap within the same short interruption. That is why describing sleep apnea as simply not breathing for a few seconds misses much of the cardiovascular story. The heart does not literally wake up, but the circulation can be pulled into a response even while the sleeper has no memory of waking. None of this means every apnea causes injury, that every person experiences the same cardiovascular effects, or that one episode can predict someone's long-term risk. The important point is narrower. A single obstructive event can temporarily interrupt the quieter cardiovascular state we normally associate with sleep. The larger question begins when that kind of interruption does not happen once. It happens again. Breathing settles. Sleep deepens again. Then another obstruction occurs. Later, another. The cardiovascular meaning changes when a night contains many of these interruptions. Blood pressure is one place where that repeated disturbance can show up. During healthy sleep, pressure often follows a lower nighttime pattern. Obstructive sleep apnea can interfere with that pattern because repeated arousals and sympathetic activation keep asking the circulation to respond. The result is not necessarily one continuous rise. It can be a night of repeated fluctuations, with periods of relative quiet, interrupted by short episodes in which heart rate, vascular tone, and blood pressure may shift as breathing is restored. So the night is not simply high stress from beginning to end. It can be a pattern of relative quiet, interruption, recovery, and another interruption. Over time, that repeated sympathetic activity is one reason sleep apnea has been studied so closely in relation to hypertension and cardiovascular disease. But the number of breathing interruptions alone does not tell the entire story. Sleep apnea has traditionally been described using a measure called the apnea-hypopnea index, or AHI. It counts how many apneas and hypopneas occur on average during each hour of sleep. That number is useful because it tells you how frequently breathing is being disrupted. But frequency and physiological burden are not exactly the same thing. Suppose 2 nights both contain a similar number of obstructive events. On one night, the oxygen reductions may be relatively shallow and brief. On another, some of those reductions may be deeper or last longer before oxygen returns toward its previous level. The event count can look similar while the oxygen burden across the night is different. Researchers have been studying this distinction with a measure often called hypoxic burden. Instead of asking only how many breathing events occurred, Hypoxic burden looks at the oxygen reductions associated with those events, including how deep they are and how long they last. Recent observational research has found that a higher sleep apnea-specific hypoxic burden is associated with cardiovascular outcomes in large groups of adults. That does not turn hypoxic burden into a personal heart risk score. It does not mean someone should look at a home oxygen graph and try to calculate their cardiovascular future, and it does not make the traditional event count useless. Counting tells you how often breathing was disrupted. Physiological burden asks what those disruptions actually did during the night. That distinction helps explain why two people can both be told they have obstructive sleep apnea, while their nights may not place the same demands on the cardiovascular system. The pattern of oxygen changes can differ. Sleep fragmentation can differ. The timing and duration of events can differ. Other cardiovascular conditions can differ, so one number cannot carry every part of the story. This also helps make sense of the connection between sleep apnea and nighttime blood pressure patterns. Repeated sympathetic activation can make it harder for the cardiovascular system to remain in the quieter state normally associated with sleep. In some people with obstructive sleep apnea, studies find higher nighttime blood pressure, greater variability, or a reduced nighttime decline in pressure. Those patterns matter clinically, but they are not something a viewer can diagnose from how loudly someone snores or from one device reading beside the bed. The same caution applies to heart rhythm. Sleep-disordered breathing has been associated with arrhythmias, including atrial fibrillation, and researchers have identified several plausible pathways connecting the two. But an association at the population level does not tell one person what their heart rhythm will do tonight. That keeps the evidence in proportion. The connection is real enough to study and take seriously without turning it into a prediction for one individual. Before this investigation, what did sleep apnea mean to you first? Snoring, poor sleep, or interrupted breathing? Has that picture changed? Tell me in the comments. You do not need to share symptoms, test results, or any personal medical information. Once the question becomes more precise, guessing from snoring, fatigue, or a wearable is no longer enough. Snoring by itself does not diagnose obstructive sleep apnea, neither does waking tired after one bad night. But repeated gasping, witnessed breathing pauses, breathing that repeatedly stops and starts, or persistent daytime sleepiness can be reasons to bring the question to a qualified healthcare professional. The useful shift is from suspicion to measurement. That matters because the person experiencing the interruptions may know very little about what happened. Someone else in the room may notice the pauses first. Or the only clue may be that sleep does not feel as restorative as the number of hours in bed would suggest. A sleep study is designed to move beyond those clues. Depending on the type of test, it can measure breathing patterns, oxygen levels, heart rate, sleep stages, and other signals that help determine whether sleep apnea is present and how significant the pattern appears to be. That is very different from trying to diagnose yourself from a phone app, a smartwatch, or one overnight oxygen reading. Consumer devices can sometimes raise useful questions. They can also produce incomplete or misleading pictures. A graph on a wrist does not automatically tell you why breathing changed, whether an obstruction occurred, or what the pattern means for cardiovascular health. That interpretation belongs to proper evaluation. CPAP is one established treatment for obstructive sleep apnea because it helps keep the airway open during sleep. But this is not a video about choosing a machine, changing pressure settings, or deciding who should use it. And while CPAP treats obstructive sleep apnea itself, large cardiovascular trials in selected populations have not shown a clear overall reduction in major cardiovascular events in the populations studied. That does not mean treatment lacks value. It means treatment decisions and expectations should be individualized with a qualified healthcare professional. If you want more evidence-led explanations of what the cardiovascular system is doing during the hours we rarely think about, subscribe to The Quiet Heart. Sleep belongs inside the cardiovascular picture. We often think about the heart when we are awake. We notice what happens when we climb stairs, walk farther, feel a pulse change, or see a blood pressure reading. Sleep can feel like the opposite of all that. Nothing to do, nothing to measure, nothing happening. But a night of sleep is still part of the same 24-hour cardiovascular life. If breathing is repeatedly disrupted, that quiet period may not be as physiologically quiet as it appears. That is worth understanding without turning bedtime into something frightening. The goal is not to listen anxiously for every breath. It is not to watch an oxygen number all night. And it is not to treat snoring as a diagnosis. It is to recognize when a repeated pattern deserves a better question. If someone repeatedly notices gasping, breathing pauses, or other persistent signs that raise concern about sleep apnea, bringing that pattern to a qualified healthcare professional can lead to appropriate testing rather than speculation. That is a calmer form of control. You are not trying to interpret every second of the night yourself. You are turning an unseen pattern into something that can actually be measured. Now, return to the bedroom. The room looks still. The person in bed looks completely at rest. For a while, the breathing is smooth. Then comes another pause. At the beginning, that silence looked like a brief interruption in breathing. Now it carries a different meaning. The sleeper may never remember waking, but even in a silent room, sleep apnea can still ask the circulation to respond.